Hi. Now, for the second part B, before I do this, I'm just going to recap on the question. For part A, I'm assuming that you watched the video for this, but essentially we were given this beam AB of length 15 meters and it was resting on two supports given at a distance of 2 meters and 3 meters from the end. And we found out that the mass of the beam was 25 kilograms and the centre of mass was a distance of 6 meters from A. So what I've done is I've now put on the weight of the beam, 25 G newtons, acting a distance of 6 meters then from the end A. So we're now told that when the child stands at the point X on the beam, and remember the child had a mass of 50 kilograms, it remains horizontal and in equilibrium. And given that the reactions at the two supports are equal in magnitude, we've got to find out the distance AX for 6 marks. Okay, now if you'd like to have a go at this, haven't done so already, I'll just give you a moment to pause the video. And when you come back, I'll tell you what the length AX was, and if you need further support, I'll run through the work solution. Okay, welcome back then if you had a go. So what was the distance AX? Well, it was in fact 7.5 meters. So if you didn't get this or just want to see how I did it, I'll take you through now the work solution. So let's just put on some more forces acting on this beam here. Now the child then has got a mass of 50 kilograms, stands at a point X on the beam, and we've got to find that distance then from A to X. I'm going to just say that the child stands, say, round about here. Okay, we'll just put the weight of the child in, and the mass was 50 kilograms, so the weight is now going to be 50 G newtons. And that means when the child is standing at this point here, X, the two reactions on these supports are exactly the same. So we'll put those reactions in and I'll just call them R. Okay, that'll be R newtons there and R newtons there. So that's our diagram. What I need to do now is just start to resolve first of all. By resolving upwards, I can find out what R is. And then I'm going to take moments about the point A. I can take moments about any point I like, but I think A would be the best because we would then straight away get the distance AX coming up in our equation. So it's going to be resolving upwards then and then taking moments about A, solving then simultaneous equations from there on. So let's start then by resolving upwards. So by resolving upwards, we're looking at what the resultant force is. And we've got R and another R, so we've got 2R acting upwards. And the two forces here acting downwards total 75 G. So that's going to be in the negative sense, so it'd be minus 75 G. And because the beam here is in equilibrium, that resultant force must equal 0. So from this, it clearly follows that if I add 75 G to both sides, 2R would equal 75 G. And then if I divide both sides by 2, from here it follows that R must be equal to 75 G divided by 2. Okay? Now, I'll call that equation 1. And next, I'm going to take moments about A. And I need to set up a sense, and I'm going to take clockwise as being my positive sense. It doesn't matter which way we take it, but I just feel that'd be the best way here. So taking clockwise as positive, then these two forces here acting downwards will want to turn the beam clockwise about A. So we'll have the moment first of all of the weight here, so that would be the force, which is 25g, and we multiply that by the distance from here back to A. So that's going to be a total distance of 6, so we've got 25g times 6. And then for the weight of the child, the moment will be 50g times the distance back to A, which is AX. And so that'd be plus 50g multiplied by the distance AX. Now we've got to take the reactions into account. So we'll start with this one here. So we've got R multiplied by 2. But this will want to turn it in an anti-clockwise sense about A. So that'll be in the negative sense here. Okay, so it'll be minus R times 2. Or 2R I could have written there. And for this reaction here, it'll be R multiplied by the distance AQ. And the distance AQ is 12 meters. Remember, the length of the beam is 15 meters, so we've got 3 meters here, so that leaves us with 12 meters there. Okay, so it'll be minus R times 12. And because the beam is in equilibrium, there'll be no resultant moment. So this moment here must equal 0. So it's just a question then of solving our simultaneous equations. And what I'm going to do is just tidy this up though first of all. We'll take this term here, 50g AX. So we've got therefore 50g AX. And now minus 2r minus 12r is minus 14r, and if I add this to both sides, well, that's going to equal 14r. And then we've got 25g times 6, so that's 150g, and if I take that from both sides, we'll end up with minus 150g there. So all I need to do now is substitute equation 1 here into this equation here. We'll just call that 2. Okay, so we'll sub 1 in 2. And what does that give us? So therefore we have 50g times AX equals, and if we put 75g over 2 in here for R, then 14 times 75g over 2 minus 150g turns out to be 375g. And we can divide both sides now by 50g to leave us with AX equals 375g divided by 50g, and you end up with exactly 7.5 meters. All right.